Welcome to the second tutorial. We're going to be picking up from what we did, well, for me it's actually yesterday. You might be looking at this just a minute after. But yesterday we used in the first tutorial the analysis launcher that is still open here in the bottom right. We used this to create analysis results in this folder, where we have a bunch of videos that were analyzed from the same flow cell. And we also used the trace dropper program to do quality control on the results in here, and got rid of filament traces that were not up to our standards and requirements. And after this, we used the spreadsheet program to actually get results from these files here. But there's also a different way to get results from this, where you would use an interface that is provided within the software. So there you should be somewhat quicker on your feet in terms of analyzing or getting results from several videos at once without having to open every single one in a spreadsheet file. And what you would use for this is another MATLAB script that I'm going to pull up here. And here are the different scripts that come with the software. And the one that we're going to be using for this is the collectResultFiles.m. So I'm just going to open this. As usual, we go and run it from here. And yes, change the folder again to go there. And here is the interface for this. How we would be starting this is just by picking result files. So that's this button here. And that pops up an interface to select files for this. And here on the left side, you can actually use this to navigate around. Currently, we're actually in the IVMA3 folder. You can see here it's the tutorial videos, the Excel analysis folder that we made the last time, and here in the IVMA3 folder. So we might want to go up one level here. And you see here is the analysis results folder, which is basically this one up here. So let's look for results in there. And here are the folders representing the different videos from the slide, and from there we are going to want to get our data to work with. What you'll be looking for is files called analysisresults.mat, and we're going to add them over here to the right side with the add button. So I'm going to put this one in here. The second one. Third. Fourth. Fifth. Number 6. And now we get them all together, and these files are the ones that are going to be used in the analysis following right after this. When you click done, these are used. If there's one you accidentally added, you can actually remove it with this button here, but these are the ones we want to use. So we're done here, and you can see here actually all the folders that we have here: 671, 671, 234, 234. These are actually showing up in the list here. So these are the ones that are going to be used. Now, let's see. Here we can also see 8 result files selected, just 8 in here. And let's just calculate the values and see what happens from there. Alright, so there's no plot coming up yet, but you see there's a little bit of output here on the command line. So let's focus on that for now. You can see first here, there's limits and thresholds, which we'll be getting to in a moment. There's inclusion options with free typo to go with it. it says complex lengths, velocities excluded, drop traces excluded. The complex stuff here we talk about in a minute. Drop traces excluded is referring to the quality control step where we excluded excluded filaments before. But here's really what we want to be looking at. You can see here mean sliding velocity with a standard deviation to it. That's the sliding velocity value as we would have calculated from the spreadsheets. And here the mean filament length. So this is calculated from all the videos that were included, and the motile fraction as well. Also get to that in a moment. And also the overall count of filaments that are in the results that we're working with, and the count of videos of 8. So we didn't have to go into any spreadsheet work or anything, but we just get the values out of here. And let's get back to a couple more options we can actually find in here. There's the option of saving as plain text, which can be helpful if you do want to go back to working in spreadsheets, but you don't want to work in separate ones. So let's try this one out. Yeah, I guess we can add it into here. Combine spread sheet. Dot. And we find it here again and open it with our spreadsheet program and find that now all the length from all these videos combined, all the filaments we find in there, and all the velocities that would be in there are now combined into one spreadsheet file. So if the need ever arises, you can just combine things here relatively easy. Okay, so let's look at some of the options that we have here. On the top right, we have Vmin, Vmax, Lmin, Lmax, and best way to make them clear is by actually putting in the option for a VL diagram, and then we'll calculate the values again. It will be clear in a second what these mean. Okay, here we are for a graphical display of the results from these videos. You can see that there's the length of actin filaments here. The velocity of actin filaments is also given, and here are actually the data points for the individual filaments. On the bottom you see a histogram that is made from there, and you can see here sliding velocities of the filaments and the count or frequency of observation of these. So yeah, you get a nice overview of what you have in your data, and there are also some circles that have crosses and some that don't, and that we should also get to in a bit. But importantly, you can see that actually the filaments occur at different lengths and at different velocities, and there might be situations where you don't want all of these to be included, which is what you have the Vmin, Vmax, Lmin, and Lmax for here. So say we only want filaments that are longer than a micron. Go here, put in 1.0, and everything below 3 microns here. So 3.0. Should be putting it in for the length. And here, all the velocities, as you put in inf, it actually means infinity, so the velocities can be as high as they want to be, and we don't put a limit on this. So let's see what this puts out as a graph now. You can see that differently from the graph here, now we have these limiting lines that are drawn in, and also only filaments that are actually between these lines in terms of length, so in this valid range here, actually have a cross in them. So here you can see what the meaning of these crosses is. these are the filaments that are selected, and the ones that don't have a cross in them are rejected. And quite clearly, only the ones inside of this range are kept. Everything outside is rejected, but also there is sometimes rejection of the filaments for reasons like quality control, so there would also not be a cross in here. Now this also has an effect on the output that we get here on the command line. So if you compare, we had 100 filaments before, now we're actually just looking at 59. So you see there's a quite obviously reduced number by applying the selection criteria. And also you can see that things like the velocity here, 0.67, 0.68, can be affected by this. So that much for the options here on the top right. So let's go for the next ones that we have here. There are these: keep, and disregard. I think the most easy to explain is the disregard trace dropping. We had the quality control step in the last tutorial, and currently the trace dropping is considered. So that means that the quality control step actually has an effect on the results that we see here in the plot and also here on the command line. In the sense that the filaments that we rejected before in the trace dropping or quality control step do not show up here, so they're taken out of our data set and don't affect the results any longer. We might decide though to actually keep all of them inside, no matter if they looked bad or not, and checking this box here would actually get them back into our assessment. We could go ahead, calculate the values, and see that now instead of having just 59 filaments, we're back up to 89. So it actually adds some of the filaments back in. However, we did the quality control for a reason, so let's keep considering it. Now there are these things here about keep complex lengths and keep complex velocities. I think for the mathematical details behind this, complex here refers to complex numbers that occur in the analysis. If you really want to get into the details of why the complex numbers show up, I would maybe say you should look into the documentation of the software, the written one, or in the paper where we actually describe the method and do detailed analysis of what these complex things here actually mean. But for now, for the complex lengths, and it's just important to know that this here affects very short filaments. So you would think anything that's below this cutoff here, below 0.6 maybe, where the filament lengths can have not just a real value in the length, but also an imaginary part to it, and then the results are maybe not as reliable as you would assume when they do not have an imaginary part to them. But it also effectively cuts you off from analyzing anything below a certain length here. So if you want to analyze really short filaments, you might want to consider to actually add these back in. You just have to keep in mind that as soon as you add the complex lengths and velocities, it's no longer ensured that a length that is shown here actually corresponds to the length of the filament in the assay. The only thing that you still get when there is a complex length is the relationship between the lengths. So you can say that anything that shows up as longer on the axis would actually be a longer object in the assay. What you cannot say anymore is it's say at exactly 0.5 microns or at 0.4, but the absolute length values are not really reliable that much anymore. So all you can really draw from here are relative conclusions, like a filament is longer than another filament. If you want to know more about the details and the extent how this affects the data and analysis and how much the lengths are shifted here, as said, the best place to look for the assessment of this is probably the paper where we describe the analysis method, and there in the supplementary you will find more in this. Now I want to give it a quick shot, see if this actually makes any differences. And it seems that even in the step before we set parameters so that we wouldn't have anything showing up in terms of short actin filaments here. So here it doesn't actually make a big difference. So for now we can just disregard them. And so looking over this, this actually appears to be mostly how you use this. You can pick result files, assemble them here. You can calculate the values in terms of velocity and length, which you get reported here on the command line. You can save them as plain text if you want to work in a spreadsheet program. Here you can limit the range that values can be in terms of the velocity, but also in terms of the length. And here you have options in terms of which data are actually going to be considered in the analysis, and also the option to put it as these types of graphs here. And this is mostly what you can do with this interface, and also what this tutorial should be about. So speak soon then.